I'll go ahead and do a test for those of you who are on this morning to make sure everything's working. There's a delay, which is a little weird. The lighting here is kind of weird. Again, I'm broadcasting from my parents' basement. I'm visiting them for the weekend, which is good overall, but makes the broadcasting a little odd. So make sure you put something in the chats if things are not working well. I have to move the computer around so I can see my notes as I'm talking. So it will be a bit. I think we'll figure it out. And again, I went ahead and posted in the chat, but just to let you know as well, if you have questions about any of the upcoming assignments, then make sure you go ahead and put them in chat, and I will probably answer them at the end, but that'll give me some time with a delay to be able to figure things out. I'll give people a couple more minutes to connect. I'm also going onto the Moodle site in case there's an issue with that. Okay, I'm starting the recording. Looks like there are 4 of us here. If more join, that's great. So again, if you're watching this later, I'm not in my normal location in the bright green room that is my daughter's room. She's away at college in grad school, so I use that for recording. I'm in a little calmer room today in my parents' basement. We're visiting them for the weekend. So that means things are going to be a little odd as far as where I'm looking and potentially the quality of things. Okay, so we'll deal with that. So again, if you have questions, put them on chat. I don't have enough devices with me at home. I have a lot more computers around. So I'm not able to look at my notes and the chat and the feed all at the same time. So I'm not able to see your chat in the same amount of time. I will try to check back and forth on it. Okay. This morning actually, the database homework was due. If you're having some issues with that, then definitely ask questions at the end. You can have some more time. It's not a problem. I really like SQLite a lot, which is odd because I'm not a big fan of databases. So I do enjoy working with that. So if you have questions, definitely let me know. And if you need a day or 2 more, that'll be okay. Also due today is the individual research project. Okay, let's do it midnight tonight. And again, if you need more time on that, not a big deal. Okay, we're coming up on the last week of class. So next week will be the presentations. The presentations will not be on the YouTube Live like the other things are. It will instead be on a Google Hangout. Okay, so I think I have everyone's Gmail account. Make sure that I do. If I don't, and basically we're going to do the team presentations. Okay, so one person from the team will be the main person who will do the presentation, but the other team members should definitely be involved in that. Okay, and yes, I'm using a Christmas mug, but hey, that's such is life. Okay, so I'm going to check the chat one more time before we get started. Let's see. Yeah, just quickly, I know there's a delay here, but it looks like Orville's having an error. And let me post it. If you're having trouble posting, I assume you're talking about the database homework. If you're having trouble posting it onto Moodle, I think the best thing for that is to just cut and paste from the screen the text of the commands that you do. I don't need a copy of the database file itself. I mean, one of the joys of SQL is that you can recreate everything just from the statements, just as a text file. So hopefully that will solve your problem. If not, we'll work it out definitely. Okay. So anyway, I don't see anything else right now. And again, I'm ahead of you. There's a delay, which makes my life difficult. But I'll go ahead and get started with the lecture for this time, and then I will check notes or check for the chat along the way. Okay. So today's topic, again, this is the last lecture I'm going to be doing in this class as far as what I'm presenting. Next week, you're going to be presenting your information. Today, we're going to talk about network security. So this core web technology class is a combination, again, of 2 classes that used to be separate. And those two classes were networking was its own class, and then we had database as its own class. The database we found was a difficult course for students with the background that some students in this concentration have. So therefore, we've moved to 1 day of database instead of one whole class of database. And I think that that's probably a good idea. Again, databases are important. If you have an interest in database stuff, you should definitely. We offer a standalone course on the residential campus about databases, and there are lots of resources out there. It's a good thing. Okay. And what we made room for in the curriculum by combining these two classes is a course on information assurance, which is a course required of the residential business students, all of them, that basically gives you some background in security analysis for businesses and making sure that the information is secure. So what I'm doing today is a subset of that, or kind of a preview of that. I think actually that's the next course that you take, if I'm not mistaken. So therefore, what you're getting today is I'm going to try to focus it on, sorry, I just checked the chat again. I was trying to focus it on the networking aspect of it rather than security in general, which we'll talk about a lot more in the next class. Okay. So I think when you're talking about network security, it's important to realize the history of the internet. The history of the internet comes from the Defense Department, and we may have talked about this in this class before. I teach a lot of classes, and they sometimes run together. But the internet was founded or funded by the United States Defense Department back during the Cold War. It was funded in a way to, or I guess its original purpose was to connect these separate computer systems that they had at the time together. Computers then were the size of rooms, and there were probably maybe 20 computers in the whole United States and less than 100 in the world. So the connections were between known systems. So if I was at Los Alamos, I could connect to a computer at Oak Ridge. I could connect to a computer at Sandia. It then expanded to universities like the University of Michigan that was doing significant Defense Department research. So everybody was known. Everybody on the internet was a Defense Department employee or contractor. So therefore, you didn't have to think so much about security. So the early protocols such as the file transfer protocol and Telnet, which were really all there was, along with mail early on in the internet's history, would pass the credentials being login and password, in plain text. So not very secure at all. So upon this friendly place where everybody knew each other, we have strapped on the rest of the world. Okay, we've expanded to gargantuan size, where everybody in the world pretty much nowadays can be, or at least getting to that point, can be connected to the internet. So we don't know everyone on the internet. We don't know all of the computers that are on the internet. So there's some basic problems with the internet and the structure of it that are difficult for us to deal with. But as a business person, you have to deal with it. The Pandora's box has been opened. There's no way to revert to a pre-internet society. There's no way for businesses to not use the internet. Okay, the risks are there, but they're just now the risks of doing business. There's no way to avoid the internet. Okay, so when we're talking about network security, the term that we always use, or the acronym that's important that sums it up, is CIA. Not CIA, the Central Intelligence Agency. Instead, we do CIA for the things we're trying to protect. We're protecting the confidentiality, the integrity, and the accessibility. Okay, so let's break those down individually. The first is a confidentiality. Okay, confidentiality simply means that information that is supposed to be private is actually private. So if you have customer records, if you have, if you're Kentucky Fried Chicken, you have your secret recipe, that should be confidential. By confidentiality, we're assuming or we're ensuring that is going to be confidential. Okay. The next one, the I, stands for integrity. Integrity means that the data should be correct and that only authorized people or entities can change the data. Okay. Integrity becomes a really big issue. Just think that if you with Walmart, if you didn't want to steal from them, but instead you wanted to hurt them some other way, you could go into their product database or go into whatever when they scan your product and change all the prices to be crazy low. Okay, that would be a way to hurt them. Or if you have patients' records, if you scramble up the numbers on test results, you can wreak a lot of havoc in the world. So that's really what we're talking about there. And then finally we have the accessibility. That's the A of the CIA. And accessibility refers to the fact that you have to be able to get to the resources when you need them. You need to be able to, your customers need to be able to. Okay. So I think we talk about it more in a minute, but we can talk about it right now that one of the big threats that businesses face when they have an online presence is called a denial of service attack, okay, or a DOS. A denial of service attack is when someone decides to shut down your web resource, whether it's a website or whatever, by just going to it a whole bunch, okay? So it's not the case that what they're doing individually is illegal. It's the case that they're overwhelming the capacity of the server with useless but not illegal activities. Okay, I guess a physical example would be if you are a mom and pop store, you're a little, or even if you're Walmart, if you get enough people to go to that Walmart, and I mean enough to totally fill the spot or fill all the spaces, then in essence you're shutting down Walmart because no one with legitimate reason can get in there, and no one's going to be there because it's way too crowded. And of course, all the people that are in the store are not doing business. They're there just to cause trouble. So denial of service accounts are easier online because one person can generate a whole bunch of requests to a website. Okay. The other problem with the denial of service is when you're looking from a law enforcement perspective, you can't determine which of the traffic that you're seeing is from a legitimate user and which is from someone doing an attack. So if you happen to go to Walmart during this denial of service attack, then your traffic looks just like the traffic of the attackers. So it can be a problem. Okay. Okay. Sorry. Allergies again. Coffee's helping. So, okay, still no other comments, so that's good. A couple other things that kind of go along with the CIA. We have a couple of other A's that we deal with, and that's the difference between authentication and authorization. Okay, those are important concepts that can be a little confusing. The first, and the system really starts with authentication. Authentication means proving that you are who you say you are. Authentication comes down to three things. It's either what you know, what you are, or what you have. Okay, those are the three categories of authentication. So the what you know is going to be a password, a PIN number, the secret phrase, whatever it is. Okay, what you have is going to be an ATM card. It's going to be an ID with a chip in it. It's going to be some other kind of device that you physically have with you. Okay, and then what you are going to be the biometrics. That's going to be something like fingerprint, voice recognition, retina scan, facial recognition, hand shape recognition, those kinds of things. Okay, so authentication is part of the authorization process. Authorization is once you've determined that I am who I say I am, do I have the rights to do what I'm trying to do? And that's where authorization. Is some user authorized to access this database? Are they authorized to do this or that? Okay. So another important concept, and again, those are related in some ways. If you don't have good authentication, it doesn't really matter if you have good authorization or not. Okay. The other term's a legal term. It's non-repudiation. Non-repudiation means that the systems are secure enough to legally guarantee that if I did something online, or if it looks like I did something online, that I really did something online. Okay. An example would be if you place an order through a system that has non-repudiation. It means that their security standards are sufficient, that they've been able to authenticate who I am and authorize that I'm able to make the purchase, that I can't later go back and say I didn't really do it. Okay. If I wanted to prank somebody and order 50 pizzas to their house, okay, non-repudiation is not there. The phone systems are not secure. Anybody can call up. They don't guarantee you are who you say you are, especially if you're using cash to pay. So in that case, that's not a situation where non-repudiation would make any sense. Okay, but on the internet, if you buy something from Amazon or whatever, legally speaking, then they can say you are who you say you are, and they can prove it in court. Although Amazon, for example, is really good about refunding things if people have trouble. But that's an important concept. Okay. And that very loud noise is the keyboard on my parents' computer getting my notes to move down. So when you're looking at threats to your network, okay, there are many sources of the threat. Some of them may be surprising. The first could be your employees. Your employees access your system all the time. They have authority to access big chunks of your system. So some of that very sensitive information. So employees are really something that you have to be careful of. There are two different types of employee threats. The first is accidental. It could be that the employee was not trying to delete all of your records, but was able to do so. Okay, so your systems need to be secure enough to try to protect against that accidental damage. There could be an accidental release of information. Sometimes people have posted screenshots about something that shows something else on the screen that it shouldn't. There are lots of things like that. The employees also could be intentionally trying to hurt the business. If you have an employee that's not a good employee, that you've had trouble with, that really hates the company, you have to really be careful of that. They can do a lot of damage. If they're looking to move to another company, they could be doing a lot of damage before they go. They could be collecting information. They could be sending customer information to the new with them when they go to the new company. There are lots of things there. So you have to be careful. Okay. If you're watching this live, there may actually be two recordings. In trying to keep my screen from dying, I actually hit the record button again. So yes, there will be two sessions, but such is life. So anyway, you have to worry about your employees. You certainly have to worry about disgruntled former employees. So you fired someone or someone's unhappy with you. They can certainly cause you a lot of trouble. So you have to watch for that. Customers. Again, you can have a customer that causes your business trouble accidentally. They're using one of your systems, and they happen to they happen to cause some other kind of inadvertent damage. So again, your systems have to be secure enough to make sure that doesn't happen. Okay. Also, you could have customers that are trying to rip you off. It happens. Just because they're a customer doesn't mean they're a good customer. Okay, I'm going to quit the coffee. Your business partners through a supply chain. Supply chain we don't talk about in this class, but a supply chain system is going to link companies from the raw materials to the finished product to the retail store, okay, through the wholesale process. So you could have partners in that supply chain that can try to hack into your business in order to get more information from you and to make their business prosper. You could worry about competitors, clearly. I mean, your competitors would love to be able to get into your information to find out what you have going on. If you're bidding on a big project, they would love nothing more than to be able to find out your bid so they can see if they can undercut you some. Okay. Then when you get to people that are not directly attacking your business, there's a problem of what we call script kiddies. A script kiddie is someone who goes online, Googles or goes to YouTube and types in how do I hack, and are able to download scripts or download pre-done techniques for breaking into systems. Okay, if you don't keep your systems up to date, then you definitely are liable to be attacked by a script kiddie. The good news, I guess, about script kiddies is that they're often caught because the hacking tools that you get online often do not tell you how to cover your tracks. The bad news about script kiddies, they are often kiddies. They're often under 18 and therefore won't really face any consequences for what they're doing. You could be attacked by a professional hacker. There are professional hackers in the world. The bad news there, if a professional hacker wants your information, they're probably going to get it. There's probably nothing you can do about it. You just have to hope that you're not the target of a highly skilled hacker. Okay, and you do want to make it so it's more difficult for them. You want to make it that you're not. We refer to in security as low-hanging fruit. You don't want to be the easiest site to break into. Okay. You also have to worry about hacktivists. A hacktivist is a combination of the terms hacker and activist, and they're people that have a political axe to grind in one way or the other, who may attack your sites or deface your websites to try to make their point. Again, Anonymous is probably the biggest of the hacktivist groups, And if you make Anonymous mad, they probably are going to steal your stuff. So don't make Anonymous mad is your best bet there. Organized crime, criminal gangs have all been involved in hacking, in attacking network security. So you have some issues there. There are people looking for identity theft, or someone can steal your identity online. Lots and lots of things to consider there. Okay, check things again. Okay, we're good. Okay, so those are the people that could threaten you. As far as the different kinds of threats that you can have, again, most things are going to be through the network. So we're going to talk about some ways to secure your network. Okay, and again, some of this is stuff that you're going to see again once you get to information assurance, but you can't cover security too many times. Okay, so the first step in protecting your data and your information and all of that is physical security. If a halfway decent hacker can touch your computer systems, then they're going to break into it. You know, if you give me your laptop, I'm going to get into it whether you give me the password or not. Because people are people, there are always ways to recover a password or change the password or get into the machine otherwise when you have physical possession of that machine. Okay, so it's important that you keep people away from the devices whenever possible. Okay, so that means you have to protect your computers wherever they are. If you have a computer room, you need to make sure that it's locked. You want to consider putting in motion detection cameras, or if it's your big computer room, you probably want security guards there. Okay, so there are lots of things there that you have to worry about. Okay, you want to have a room with no windows if you can. If you're a business where you have customers in your space, in your workspace, you want to make sure that your customers can't get to your computing devices without some trouble or without being obvious. Okay, the bank that I go to, the teller's computers are right there on the desk. Okay, the USB ports are clearly available. I could shove something, shove a drive with malicious software on a USB stick into their computers, and they would never know it when they look away to ask somebody a question. So they really need to protect that. You need to not, your customers should not be able to grab your computer when you're not looking. Okay. Let's see what else we got from there. I think that's most of it. Depending on the size of your business, you really could get a lot more involved. Computer rooms often should be out of the way. They shouldn't be well marked. It should be, if you know where they are, you know where they are. If not, you don't. Okay. You also have to worry about, I think you have to worry more about the systems that are not located in one central location. Things like your wiring closets. Okay. When you're doing your diagrams for your final project, you're probably going to have to put wiring closets along the way. Okay, so if you have a set of offices that are a fair bit away from the main part of where your computer, where your outbound router is, you have to put a wiring closet there. There'll be a switch in there at least, maybe a router. Okay, those wiring closets should be locked. They should be unmarked. They should be protected against fire and water and all those other things we have to worry about. Okay, that's the next section I'm going to talk about. Your wiring becomes an issue. If you're using traditional, either the coax or twisted pair wires, both of those leak electromagnetic information. And if you can see that wire, physically touch it in your hand, you can get scanners to get a lot of information from it. Especially with the coax, excuse me, you can actually tap into that and become a node on the network and connect your computer and get all kinds of information that's traveling by. So there's certainly some issues there as well. In addition, someone just may be able to physically cut the wires. I mean, just for meanness, just for no other reason than that. Okay, fiber optics don't have that problem of leaking information, but they can be cut pretty easily. Okay, and they're harder to fix. When possible, wires should be run through raised floors. You probably work for places that have the little raised floor panels where all the information goes there. Your raised floors should have locks on them. You can get lockable raised floors where you have to have a key to be able to open up the panels. Okay. So the computers that just are on desks or whatever need to be locked up and secured to the desks via some way. You can chain them to desks. You can do all kinds of things. Again, it depends on how much access people have. If the office is typically not left unguarded where people could easily get in and out, you probably don't have to go to that trouble. Okay, but you do have to worry about these things. You want to make sure that you have, your nighttime security guard goes through and make sure that that things are locked, all the doors are locked. That's an important thing. Okay, laptops become a special issue, special concern, especially if they leave the premises, which they often do. Okay, so you want to make sure that each password or each computer, each laptop that goes out has a strong password. But again, just like I said, if somebody physically has your laptop, they are going to be able to get to your information. You can't stop them. Okay, so the second level there becomes you want to encrypt the hard drives. Every operating system that's modern, in the last couple of years certainly, has the option to do a full hard drive encryption. Okay, with that, you're basically protecting all of the data on the hard drive. No plain text is stored on the hard drive. You have to type in some kind of a code to get to it. Okay, it slows down the system. It means you have to type in a fairly long password every time you get on the computer, but in the long run, it can be worthwhile, especially if you have sensitive data. There have been a bunch of breaches from either the Social Security system or from the Veterans Association, the VA, Veterans Administration, because they've had their workers take data home to work on at home, and the laptop gets stolen. So that's a problem. Any business that has laptops, you're going to have laptops stolen or left in taxis, left in hotel rooms, all kinds of things. So you really have to be careful about that. With encryption, somebody can steal the hard drive or have physical access to the computer, get into the operating system, and still not be able to get to the files that are stored there. So that's a good thing. Again, just costs a little bit of time. If people are connecting into the home network, you want to make sure they're connecting through a VPN or a virtual private network. A virtual private network is just a way to create a secure channel through the insecure internet. The internet itself is not secure at all. So a VPN allows it to be more secure. Okay. You also have to worry about people who bring in devices from home. You have smartphones, you have tablets, you have all kinds of things that are highly adapted to stealing information, if that's what you want. Everybody pretty much these days is carrying around a high quality phone with them at all times. Okay, so if you have sensitive processes, sensitive manufacturing processes, things like that can be a problem. Okay, if you have Wi-Fi that's available to them, that can connect them together. Okay, all kinds of issues there. Okay, so there are lots of things you need to be cautious of, and your company should have clearly designed policies in order to make sure that things work out well. Okay, so you also have to worry about natural disasters, floods, fires, tornadoes, hurricanes, depending on where you are, earthquakes, all kinds of those things. Okay, so it's something you need to talk about as a business. You want to make sure that you are planning for those and you're taking appropriate steps. Okay, in information assurance, you'll probably talk about the whole risk management process, which is very involved, but it's basically identifying all of the assets that you have and looking at what threats you could have to those, and if there are ways to control or mitigate those requests. Okay. So again, the internet is inherently insecure. Okay, so security has been built on top of what was already there. Okay, so here are some tips on keeping your communications secure on the internet if they need to be. First, you have to try to keep the communication itself from being intercepted. Okay, and that has to do with making sure your wires are not exposed. Making sure you're not connecting. One of the big things is if you're at a hotel, you connect to the Wi-Fi that you think's the hotel's Wi-Fi, but it may not be the hotel's Wi-Fi. That could be a real problem. Things like that. So your communication can be intercepted right away. Okay. Also, if you have a VPN, it's going to decrease the chance that your messages are intercepted. Okay. You also want to encrypt the data. And again, encryption is just taking plain text, an email message, a sentence, whatever, or even an image, and converting it into what we call ciphertext through some mathematical means. Okay. So I'll talk more about encryption here in a second, but that's the basic idea. You want to control access to your systems. You want to make sure that you have good authentication and authorization plans set up and that they're working, okay, so people can't get there. You want to make sure you don't have unrestricted Wi-Fi that connects into your systems, things like that, okay? Now, it's usually a good idea to create a security perimeter around your business, where there's a difference between internet traffic coming from beyond your local area network and those inside. So inside the security perimeter, you can allow for more freedom of communication and freedom of information exchange. But if things are coming from the outside, it gets a lot more complicated. Again, the VPN is useful there. When you connect into a network via a VPN, it's just like you're really there. So it's not perceived as being from the internet. So that makes a difference. Okay. So again, encryption is very important. Okay, it's a mathematical process. There are two basic types of encryption you should know about. The first is symmetric encryption. With symmetric encryption, you use one key to encrypt the message and the same key to unencrypt the message. Okay, so if we're looking at physical locks here, if you lock up, put information in a box, you lock it up, you send it through UPS, on the other end, exactly the same key will open it. Okay, so that works. It's fast. It's been around for a long time. The problem with that is how you would exchange those keys. Okay, so if I know you, we work in the same office, and we can exchange keys before you go on a trip, well, then we can certainly not have a problem. But if I'm trying to create a secure communication or encrypt a message to someone I don't have physical contact with, there's not a good way to send that asymmetric key. Okay, so from that developed something we call public key encryption. Okay, with public key encryption or asymmetric encryption, you have two different keys. You have a public key and a private key. Okay, so again, you'll get more detail in another class, but just the broad overview here. The way that works is that if I know my private key, everyone else knows their private key, but only their own private key. But I know everyone's public key. Okay, the public keys are kept at an organization called a certificate authority, so you're able to go and see whose that is. Okay, so it makes it easier than trying to do the encrypted method. Okay, so let's say that I'm sending information to Orville. Okay, I think Orville's listening today. I saw him comment on there. Okay, so what I want to do, I want to ensure that only Orville can read it. Okay, so I'm going to go to the certificate authority. There's spider webs hanging above me. I'm going to go to the certificate authority, and I'm going to look up Orville's public key. Everybody can know that. Okay, I'm going to encrypt my message that I'm sending to Orville with his public key. Okay, it travels through the internet. It goes to a bunch of different routers ran by different people. Anyone who has access to any of those routers can read my messages, but none of them can unlock the message. The only person that can unlock the message is Orville. It takes his private key to unlock something locked with my public key. Okay, with his public key that I put on there. Okay, so again, if a private key of someone locks it, then that same person's public key will unlock it, and vice versa. Okay, so again, just to reiterate in case I got confused there, or maybe you did too. If I'm sending a message to Orville, I will look up his public key. I will encrypt my plain text message with his public key. It goes to the internet. When he gets it, he uses his private key to open the message back up. Okay. The other thing you can do with public key encryption is electronic signature or digital signature to verify signatures. Okay. The way that works, let's say I'm going to send a message to all of you. Okay. And I don't care who can read it. It's not sensitive in that way. But I want you to know that it's really from me. Okay. What I can do, I'll take my message, I'll sign it with my private key. Okay. As it goes through the internet, anybody with my public key can unlock it, which everybody has my public key. Okay. But if you use my public key and it unlocks, you know it must have been me who encrypted it. Where if you get something that says it's from me, well, you look up my public key and you try to unlock it and it doesn't unlock, well, then you know it wasn't from me. Okay, so that's the basis of how electronic signatures work. Now, you may think to yourself, well, I've used these kinds of things before. Certainly, if you get on the internet and make a purchase, you've used public key encryption. And you may be saying to yourself, I don't know what my public key or my private key is. Well, you don't. Your browser will take care of all of that for you. Your browser and your operating system work together to register for you a public and private key, so that every time you buy something from Amazon, when you see the HTTPS, which is important to look for when you're buying stuff online, you know that public key encryption is going on. Okay. So that can be a little bit complicated. And again, you don't need as much detail here as you will for other classes. So I will wait just a second. I am going to release the notes. The notes have some more information about that, some examples of how to work that out. Okay. So I'm going to go back to the chat. Hopefully by now, if anybody has any questions, they've posted them. Okay, don't see any questions on that. Okay. Okay, again, so there are numerous examples in the notes that I'm going to be putting out there, which is good. Okay. Okay, let's talk a little bit more about access control. We're getting near the end of the lecture. Okay, so access controls, basically, again, we talked about that. An access control is authentication and authorization, basically. Okay, so when you do that, you're doing that to keep people from getting to data that they don't have any business being able to access. Okay, that's really what we're talking about. So we can control access to systems in three ways. I said this before. Is there anything different here? What you know is password, passphrase, PIN number. Sometimes it'll ask you for your mother's maiden name. It could be what you have, ATM card, could be cell phones, other hardware things. And then again, the what you are, the fingerprint, voice pattern recognition, and retina scans. Okay. Pros and cons to each of those, but I guess what I want to talk about more at this point is the idea of a multi-factor authorization, or a two-factor authentication, sometimes it's called. Okay. If you think about the ATM machines, okay, ATM machines only ask you for a 4-digit PIN number. If that's all that was needed, it would be a horribly insecure system, right? There are only 10,000 possible combinations of numbers. Okay, not much at all. Okay, so and the odds are there's more than 10,000 people that need ATM cards, so it just wouldn't work. Okay, so when you're using your bank ATM, you have two factors, right? You have the physical factor, the what you have. You have to have your ATM card. Okay, and then you have the what you know, your PIN number. Okay, those two have to work together. So that's certainly a good system. And whenever you're looking at designing access to your computer room, you probably want to have multi-factor. You may want to have a fingerprint scan, which is fine, but can be hacked. Have a fingerprint scan and an ATM type PIN, or have a fingerprint scan and an ID card you have to have with you, or something like that. Okay, the more factors you have, the greater the security level is. Okay. Also, on the web, a lot of times nowadays, I know with Google, I have set up the two-factor authentication. That means basically, whenever I log on to a computer for the first time with my Google account, I type in my login ID, I type in my password. Google sends a text message to my cell phone. Okay, that text message has in it a 6-digit number that I have to type in to the browser in order to get access to Google on that system. Okay. Now I have the option to say, don't ask for it again on this computer, or I have an option to, if it's a public terminal, I'll unclick that and say, no, ask for it every time. Okay. And what this does for you, even if you knew, I can tell you right now on this cam what my login ID and password is to Google, you still wouldn't be able to get into my Google account unless you also had possession of my cell phone. Okay. Or were able to somehow redirect my messages. Okay. So definitely all of the major internet firms these days, like Facebook, like Google, I'm guessing Amazon, but I haven't tried Amazon. I really should. That would be a good thing. Have this two-factor authentication, okay, which it's worth the trouble. I almost didn't do it because I thought it was going to be too much trouble. But again, because once you're on a computer and you click on Don't Ask Me Again, it will not bug you every time you get onto something. So it's a good thing, okay? So that really does put more barriers between your information and the bad guys. Okay, so good stuff. Okay, again, we talked a little bit about the network threats. Denial of service ones are a big one. They keep sending legitimate traffic in great numbers. One of the more damaging things lately is called the DDoS, the D being distributed denial of service attack, which means it's multiple computers throughout the internet attacking you at once. Okay, Anonymous, again, is the most well-known hacktivist group out there. I think Anonymous does some good things sometimes and some bad things sometimes, as most groups like that are likely to do. But one of the tools that Anonymous deploys is a little software program called the Low Orbit Ion Cannon, which is a quite fanciful name, that basically it's software you can download on your computer if you want. You can also get it as malware. We'll talk about malware in a second. And that you can go to a website where you think you're looking up something different, and it will, in the background, load this low orbit ion cannon program onto your computer. Once it's on your computer, whether you put it there or whether it got there illegally or without you knowing it, someone at Anonymous has control of all of these computers. If you decide that you want to attack Walmart, you just log on to the control panel and say, okay, I'm going to send a message to all of the computers in the world, which there are millions, that have this software loaded, and it's going to start sending requests to Walmart all at the same time. It's going to overwhelm their systems. Okay, so denial of service attacks, distributed denial of service attacks, are a fairly significant threat to businesses. Okay, you can also have a passive tap on your system where someone's able to listen in on your data. Everything's a risk. I'm using my cell phone camera here. Yeah, there it is, or my laptop camera. Yeah, anytime on my computer, it could be on. The government could be watching me. It could be. I didn't mention that under the threats. I really should have. In addition to the other sources of threats, the U.S. government, we know, is monitoring what we're doing. They're accessing our information. We didn't know it before, but Edward Snowden blew the whistle, and now we know that. It's not just the U.S. Every government in the world is trying to steal information about everybody else. So there definitely are some threats there. So you have to worry about someone being able to tap into the camera on your cell phone. We should all, but we don't, cover our laptop cameras, cover our cell phone cameras when we're not actively using them. There probably are devices to do that, little stickers. If not, there should be. It's a threat. I know there was a school administrator, some school district somewhere, a high school administrator. They were giving their students laptops to take home with them to do their schoolwork. Well, they'd installed a program that allowed this administrator to look at what was going on out through the laptop cameras without the little light coming on. Scary stuff. I mean, as a parent, that would be a horrifying thing to have happen. So you have to watch that. And there's so much out there that's difficult to do much about, but you can cover up the cameras on your devices. Okay, that's a passive tap. There's also an active tap, and that's where someone is able to get into your systems and actually make changes. Again, it's much easier to damage or listen into a business than it is to make active changes to the data. So that's where you get a lot of the problems with the distributed denial of service, and it's where you get a lot of issues with vandalism. Okay, all those are problems. So let's talk a little bit more about malware. Again, when you think of malware, mal is the Greek or Latin, probably Latin root for bad. So malware is like software that's bad. Okay, so let's talk about a taxonomy and some preventative tactics. Okay, the three basic types of malware: viruses, worms, and Trojan horses. Okay, a virus, very similar to a human virus or biological virus, can't stand alone. It has to be embedded in some other program. Okay, they can spread from computer to computer by itself. Okay, worms in some ways are the worst of all possible worlds in that they're standalone programs that can also spread on their own. And then a Trojan horse is a program that appears to do one thing and probably does one thing, but also does something else. One of the biggest sources of problems, especially on Windows computers, are free screensaver programs. Almost every time I've talked to someone, especially if they're older, they'll have a really cool screensaver of Bible verses or pictures of flowers or pictures of puppies or whatever. That may be fine, but it could also be a Trojan horse software, which means that in addition to being a screensaver, which it is, it's also going to be, tracking stuff on your computer and giving you worms and viruses and all kinds of other things. Okay, so there definitely are some problems. Okay, to combat against malware, a couple of things. First, you want to be careful the software that you download. You want to make sure that it's legit. As a manager of a business, you want to make sure that your employees are not downloading software that's unauthorized. Games are another problem. If you download a game, it could have some other stuff in it that you don't want. Okay. You also want to make sure that you have running antivirus and anti-adware is the other thing. Adware is an interesting thing in that it's supposedly legitimately there to track your shopping purchases to improve your life experiences or something, but it can really overwhelm a computer, so you probably don't want that either. Okay. If you're running any version of Windows, you have to have antivirus, anti-malware. Okay, and you have to have it right away. The computer I'm broadcasting from right now had Windows 8 when I got it. I've upgraded to Windows 10, which is a whole other privacy issue that's a topic for a different class. But the first time I was setting up the computer, I was trying to download and install the anti-malware, antivirus software. My computer was infected before I could do that. So it was infected out of the box within minutes of me first connecting to the internet. Okay, so it is really important. If you're on a Macintosh, life is better. Okay, it's not perfect, but it's better. A couple of reasons for that. The Macintosh operating system, back when the OS X came out, which has been a while now, totally broke from all their previous versions of software. Totally broke compatibility. So they went from what had been a single user system, which Windows and Mac both were previous, to a true multi-user system by piggybacking the Mac OS off of a Unix variant called FreeBSD, okay, or OpenBSD1, I forget which. So there are some inherent superiorities security-wise from a multi-user point of view when it comes to the Mac. Okay, Windows has never made that clean break from existing code that they need to, but it would make a lot of people unhappy, so they don't. Okay, so that's kind of where we're at. And also Linux, because most of the hackers and most of the security researchers use Linux. I'm a big Linux guy myself. There's not really been a significant virus on either of those last two platforms. There are some vulnerabilities though on the Mac and on the Linux. So especially on the Mac, it's worth having some software to take care of that. If you have software, it has to be able to update itself on a regular basis. Okay, you have to do that because there's new malware released every day, at least potentially. One of the big problems we run into nowadays is what's known as a zero-day threat. Okay, the zero-day threat comes in where companies like Microsoft have, I think it's a monthly release of updates. Okay, so it's going to fix all the problems that they found out about during the previous week. A zero-day flaw is where you release your new malware, whether it's a virus or a worm, the very day that patch comes out. That gives Microsoft no time to fix it before they've released their next version. Okay, so that can become a problem. Okay. Another concept that is very useful for us when dealing with the internet is called defense in depth. Okay, defense in depth is just the idea that you're not just putting a strong exterior to the world, but that you're having layers of security. Okay, so if you have a physical office, or even at your house, or a house isn't as good. Let's say you have an office building. An example of not using defense in depth would be to spend all of your money on a wall around the business. Okay, it's a great wall, right? But if an attacker were past that wall, everything's wide open. Okay, you don't want that. So defense in depth means as a business that you spend some of your defense security budget on the outermost outward-facing routers, the bastion routers we call them sometimes, or the outpost routers. But you also have to worry about security at different layers. You want every router in your business to have some security consciousness. You want the computers on people's desks to have strong passwords, things like that. Okay, so a couple of ways to do that. Again, a lot of it's just planning and planning your budget correctly. It's also important that you do things like end-to-end encryption. Okay, end-to-end encryption means that the message is encrypted before it's sent onto the network. It then gets transferred along as an encrypted message. It's never in plain text. That's kind of opposed to link encryption, where the encryption happens every time. There's a different encryption every time, okay? But there's nothing saying you can't do both. You can't link the original plain text message, can't encrypt that right away, okay, send it off to the internet, that it then gets re-encrypted at every step along the way. Okay, so encryption is really an important thing to do. Again, think about the laptop issue, that you want to try to physically secure your laptops. You want strong passwords. You want to make sure they're not left in bad places or whatever. But if all of that fails, Defense in Depth says you've also encrypted your hard drive, okay, just to give yourself extra security. Okay. Other things you can do, again, we talked a little bit about tunneling. That's where the VPNs come through. It allows you to create the secure encrypted channel through an unfriendly and insecure network. Okay. The last things I wanted to talk about today, last thing, is the Internet Protocol Security, or IPSec. Okay. Internet Protocol, as we talked about before, is the network layer protocol. That's the protocol that is responsible for delivering messages from one computer to another computer across the internet. Okay. When your message leaves your computer, it starts at the application layer from some, email or web browser or whatever. It's going to go down to the physical layer, but then as it goes to the internet, it's going to go up to the network layer at every router. Okay, so it goes through up to the network layer, and so forth. Okay, so the IP address is really the address that we worry about on the internet. Okay, so that layer by default is not secure at all. It just sends things in plain text. It's also not reliable. Okay, if you want reliability, you have to build it in or use TCP at the transport layer. Okay, but IPSec basically is a way, it's a suite, a protocol suite for authenticating and encrypting each packet of a communication session. Okay, so it has to be a per session basis. Okay, if you connect to a website with the HTTPS, then you're using some version of IPSec. Okay, so IPSec is an end-to-end security scheme, okay, at the internet layer, which means that it's going to protect data flowing between a pair of hosts. Okay, so it's a very useful thing for that reason. Okay, so the basic way it works, we talked a little bit about encryption, so we'll just give a quick overview of that, is that it first does, because again, you're connecting to people that you don't know on the internet, it's going to first have to do a public key encryption. Okay, so if you're a business that's going to do e-commerce, you have to get a certificate or your public-private key from some certificate authority. Again, those tend to be free for individuals, but if you want, as a business, you have to pay for those. Okay, that allows you to do the secure transactions. Okay, so the public key encryption is used to connect to the other end, make sure things are good. Okay, and what's going to happen is they're going to send a session key. Okay, so basically, if I wanted to have secure communications with Cynthia, okay, I would send her a message telling her I wanted to do communication. Okay, I would then, I forget which way it works. Either she sends back to me or I send back to her. Let's say I send to her a key, okay, a symmetric key we're going to use. But I take that symmetric key and I encrypt it with her public key. Okay, so now I'm securely delivering through the internet this session symmetric key. When it gets to her computer, she would use her private key to unlock that symmetric key. Okay, again, just good for that one session, so it's called a session key. And now we're going to encrypt everything using symmetric encryption once we've used asymmetric to pass the key. And that's because the symmetric is much quicker, much more efficient, okay, much easier to use. Okay, so the actual protocols there are the SSL, you hear that a lot, Secure Socket Layer. TLS is Transport Layer Security, which is a thing that's also used a lot these days. And the SSH, or Secure Shell, which allows you to connect into systems and telnet, kind of like what we do telnet before, but to do that in a secure fashion. Okay. So also the VPNs, the virtual private networks, are all going to use some protocol from this suite in order to make the security better. Okay. So that's what I've got for the notes. I will be releasing those notes, okay, at some point. So again, from the networking point of view, because that's kind of this class, and the database security we didn't really talk about. So I guess it's important to add that in a little bit. When you're dealing with the database, there's the temptation to give everybody access to everything. Okay, that's a really not a good idea. The databases now, the modern systems that we use, as I talked about last week, really have the ability to lock down any table, any field, anything. Okay, so, but you have to create users with those custom privileges. So it takes a little effort, but you certainly can do that. Okay, so you definitely want to take some time to secure the network, to make sure that you're watching what comes in and what comes out, and all of those things. Okay, so that's it for, I guess, the material for this class. I will release those notes. They're all out there. If you have any questions on anything today or anything in general, let me know. I see one question here. I'll get to it just in a second. The first, again, let's just go over it again. The the database homework was due today. So if you need some extra time, no problem. Just let me know you're having trouble. I've looked at a couple of them that looked fine. If you have particular questions, let me know. I think it's important. I think, in fact, the question here is Orville's having a question that is trying to. I'm not sure, and if you can let me know, Orville, on the message or in the chat. You don't need to upload the database file at all. I mean, all you have to do basically is get onto SQLite, type in the commands you need to, open the database, create each table, and then type out the queries, and it will display the results on the screen. Okay, so once you've done that, and I think I know at least somebody, Mandy, I think, has already turned in homework. That it looks like you did what I would have done: just cut and paste the text from, select it with your mouse, control copy, control paste into like a Word document or a text file, and send that. And that transcript is what I'm looking for. Okay. You don't have to worry about saving the database file or any of that stuff. Okay, so I'm not sure if you've heard any of that, Orville, but I'm not sure what you're trying to send that's giving you trouble. Okay, so if you could answer that on the chat, I will try to figure that out. Okay. The other thing is that your individual research paper is due, I think, at midnight tonight or 11:55, something like that. Again, if something in life has intervened, then definitely, if you need a little more time, that's okay. But we're coming up to next week being it, so gotta watch that. Okay. So one other thing, next week's the final project. Make sure that you're working with your team, getting things going. See how that all plays out. If you have questions about that, you can ask those now. In addition, there will be another homework assignment today that I will post on Moodle later. Okay. Not 100% sure what it's going to be. I've got a couple of options that will be due next week. Okay. So let's see, we've got some questions coming up. For the final project, do we need to set up the database with 100 employees? No, you do not. For that, if for the database needs of the business, you just need to tell me what that would be. Okay, so as far as what you should put in the tables, that's up to your business. I mean, that's the question, right? So you need to determine the database needs for your business. You don't need to actually make it happen. Okay. So you've got 100 employees. If you have an employee table, what are you going to need to put on there? Well, whatever you think you need, right? So that's really up to you. In your documentation for the final project, you'll want to put, we're going to have this table and these are the fields. We're going to have this table, these are the fields. But you don't have to actually make them real. Okay. So let's see. Orville's problem. I'm getting a syntax error when I try to create the faculty table for the student table. It's fine. Oh, I thought you have a table. I thought you were having a problem uploading it. Okay, I'll take a look at that after the class session to see if I can figure that out. I thought you were having a different issue altogether. Okay. In looking at some other things you've sent me, Orville, I think you want to make sure that you're opening the database. And also, either my screen was funny or I saw a space in your database name. You can't have a space. It's got to all be one word for the database name. I'm not sure if that's your problem. I will look at that again. I wasn't understanding what the problem was. Okay. And then Mandy has offered some advice, it looks like, on, let's see, To right-click in the header of the current screen and choose Edit to get copy and paste features. Okay, good. Is that a Windows version, Mandy? I'm assuming it is. I didn't have to do that in Linux or Mac, but that doesn't mean anything. Okay, but that's definitely the best way to do it. Okay. So I will look at Orville's problem definitely and get back to him today. Anybody else have any questions on anything? Yes, Mandy is on Windows. That's good. The delay really does drive me crazy. Okay. Okay, so that's all I've got today. I'll ramble on just a bit more in case anybody has any questions. I think there's about a 20-second delay typically. Okay. If you're having any problems with the group assignment, if people are, you've got people who've gone AWOL or other issues, let me know. Okay. And then just a little more business that's not related to the class, but again, give more time for you to get your questions typed out before we end. The second class of the 4 is going to be offered block 2. And that's the information assurance that Ron McAllister is teaching that one. They're going to offer the other 2 classes in the sequence, which is going to be the web design and the e-commerce classes next year as well, next semester as well. So I think that in whatever the equivalent, I'm not sure how the GPS blocks work, but whatever happens right after Christmas, okay, in block 5 for the residential college, we're going to be offering the web design course. And either I'm going to be teaching that, or Ron McAllister, who's going to be teaching the information assurance course that most of you will take next, will be teaching that. One of us, we're not sure. And then I'm guessing that the other of the courses that you need for this sequence, which is basically going to be the e-commerce course, kind of the capstone to this concentration, is going to be probably toward the very end of the year, either in block 7 or block 8, depending on how our teaching schedules work out. Okay, so you will be able to, this academic year, get all 4 of these courses in. Okay, and it will be offered every year if you have to take them next year, as far as I know. Okay, so Orville has a question. We're going to do a hangout. We certainly could at some point if people want to do a hangout. I'm not sure I have time to do it today, but we can certainly set up a time if people want to have a little more freedom to ask questions. Okay, so if there is interest in that, then definitely put something in the chat window. Okay, we're on a block break on Monday. Oh, for Orville's issue in general. Yeah, let me take a look at that, Orville, and I will send you an email. And if we need to talk, we can certainly do a Google Hangout to improve that. Okay. Yeah, that has the advantage that you can share your screen with me and I can see what's going on. Okay. So let's see what else we've got. Get some questions in here. Yes, Robert, you can have more time. No problem with that on the homework. I'm glad your questions have been answered. That's good. Joel has something. Needs to resubmit homework. Uploaded the database and set up the test. Yeah, that's fine. And please do resubmit because with the text, I can see what you've done and I know right away, if there are issues. Where if you upload the file, I have to try to download it and upload it to my systems, and I don't have an SQLite system with me today. I've only got my Windows computer. So yeah, that's perfectly fine that happened. These things happen. Okay. Anything else? Any other questions anyone has about anything? I will wait out the 20 seconds until that catches up. Let me do a last call motion. I'm going to wave my hand so I know when I see that on the screen that everyone's had their last chance to submit any questions. Yeah, I'm just waiting, babbling uncomfortably, waiting. There we go. Okay, so I'm going to assume now that everybody has had a chance to ask any questions. Again, many of you have sent me email. That's fine. Continue to do so. You can, I don't always understand your email, as Orville can attest to, but I will continue to take a look and see if we can get stuff straightened out. Okay. We can also have, if anybody wants just to talk on Google Hangout about something in particular, if you're having trouble with your teammates or trouble with the project, that's fine as well. Just send me an email. We'll set up a time and we'll figure it out. Okay. If there's nothing else, I guess we will call it quits for the week. Again, that's the formal part of the class over. Next week will be the student presentations. We will be doing that next week via Google Hangout. So again, I think I have everybody's Google information. But make sure that next week you go to Google Plus or plus.google.com. Is where you should be hanging out at, and we should be able to set things up from there. I will try to post something to Moodle just to make sure we're all on the same page for that. Okay. The presentations can take a couple of formats. If you want to do a little PowerPoint, that's probably the best of all possible worlds. Okay. With that, then you can share your screen with everybody else, and we can all click on and watch your slide presentation. And on that, in fact, the multiple teammates can have their microphones turned on, and that should work out well. Okay. So I haven't done these presentations via the computer before. This class has always been in person up until now, at least partially. So it'll be interesting to see how that works out. Okay. But I hope you found this to be a useful class. I hope that the project's been useful. I'm trying to give you an overview of the technologies that make the web available, okay, that make it work for us. Okay. And again, you'll go on from here to talk about information assurance, and then you'll do the web design and the e-commerce. And I think the web design especially is a lot of fun. The students tend to like that a lot. Okay. So if that's it, if there are no other questions, we'll end for today, and make sure you send me any other questions that you have. Hope you guys have a pleasant weekend.